Okay, so yeah, welcome to CSCE 430. This is going to be a very, very different setup than we've had in the past. I'm one of those people who I feel like I could do a great job if it were in person. I feel like I could do a great job if it were online. I don't know how this thing's going to go. I appreciate those who came here into class today. We've got what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 people out of about 90. So about 1/6 of the class is here. Thank you for coming. So I hope that you find it useful to come to class. My goal is to make this more of an in-person class where those who are remote will still get something good out of it. And I'll talk a little bit about how that's going to work as we go through. So let me talk a little bit about this course. So this is a course about programming. It falls, for those of you, I assume you're pretty much all computer science majors, this falls under the software track in the department. And because it's in the software track, it's supposed to be something that teaches you about software development. You might have noticed that the prereq for this course is algorithms, and I'll go into why that is in a minute. But basically, this course is about problem solving. It's about how to do problem solving in a programming environment. So that means, how do you analyze problems? How do you figure out what algorithms to apply? How do you actually go about implementing those algorithms? How do you test them? And then even more so, how do you do all of this quickly in a time-limited environment and accurately? And so the format that we're going to use for this is a competitive programming format. So if any of you have done competitive programming before, like a programming contest, a lot of this will feel familiar. If you've never done competitive programming before, hopefully you'll get very used to it quickly in the first week. It's not that complicated to do, but it does take a little bit of getting used to on how the whole thing works. And you'll see how that goes. So when we talk about competitive programming, what that means is we are going to have problems, and I'm hoping to run through an example later. But we have problems, and the problems have a very well-defined input format and a well-defined output format. And your job is to write a program that takes that input and produces the correct output that can be auto-checked by an online system. Okay, so this is not a class where we're going to be examining your code for quality. It's not something where we're going to be looking at the details of how you do it. It's more, does it work or not? Does it actually get the results that you need to or not? One of the other things about competitive programming is it's usually done in a competitive environment, which means the other people who are in your contest or in your class in this case can sort of see how everyone else is doing. And that means that you'll get to see whether people are, whether other people are solving problems, whether you're kind of behind or ahead. It lets you sort of judge yourself relative to other people. Now, there are some big benefits to competitive programming. One of the reasons I've been the coach ever since I came here for the competitive programming teams that we have. I'll talk about those probably off and on as we go through the class. One of the reasons why I think this is a very useful way of approaching things is it's a way of really sharpening your programming skills a lot. When you come out of this class, almost universally, people tell me, regardless of anything else, they're much better programmers than when they started. When I do surveys, that's, pretty much everyone has said that. 1 or 2 people have said, no, I hated this class, I didn't get anything out of it, I wish I'd never taken it, and so on. But most people come out of it saying they're much better programmers, even if there were things they liked or didn't like about it. It also will familiarize you with algorithms. So 411, the algorithms class, that's a prereq for this. When you go through that class, you solve some problems, you do analysis, you learn these algorithms, but you don't really get the chance to apply them. You don't get to see a problem, even if it's sort of a toy problem, that you actually need to implement that and use it and so on. And this is an example where you'll get to do that for lots of the algorithms that you should be familiar with already, as well as several new ones. It lets you deal with a lot of challenges in a short period of time. So you're going to have multiple problems. You're going to get to do lots and lots of different programs. You're not going to have one big project. It's not like 315. 315 is kind of like the other end of software development from this. So in 315 or software engineering, you're working on a big project with a group of people that extends for a period of time, and you might have to go through multiple cycles and develop it more and more. In these types of problems, you're going to have short problems, relatively short. Some of them will still take time to develop, but you'll have one problem, you're done with it, it's behind you, you move on to the next thing. And so that does let you cover more things more quickly as a result. It also encourages you to deal with time pressure. When we have our lab time on Friday, it will be somewhat pressured in terms of time. It's not going to be super, super pressured, but you will be under time constraints. You have a limited amount of time to work on problems. And what that means is that you need to be able to think quickly and program quickly. And that's one of the goals of this class, is to learn to do these things fast, to actually operate in a time-constrained environment as you do that. It also lets you really judge yourself versus others. So a lot of times people, they program and they're like, oh yeah, I'm fine at this. And then you compare yourself to other people. So software development is one of these things that when software engineers have looked at it, you can find the best programmers versus the people down. It's almost an exponential growth, not quite, but in ability. So the very best programmers can be multiple times better than people who aren't quite as good, but are still pretty good. And they can be multiple times better than the people lower than that. Okay, and this really can let you see kind of where you fall on that spectrum, and are your skills good? Are there areas where you can improve, and so on. It can be kind of humbling. It's very humbling for me when I do these contests and I see people who are just blowing me away on them. Okay, and I'm like, I'm not a good programmer. I can at least claim I'm old, right? But anyway, it lets you really judge yourself and see where things are. Now there's some drawbacks to this. So some of the drawbacks are this can teach some bad programming habits, because people who do competitive programming, you tend to take shortcuts. I said we're not going to look at the style of the code. I was someone who way back when in the earlier iterations, it's quite a bit different now, but I developed the 315 class, because all the stuff that you're supposed to learn in 315 is really useful stuff about how to write good code and how to use good variable names and how to make things that other people can work with. And all of that stuff is really, really important in the real world, okay? And much of that gets ignored here. And you're somewhat encouraged to just name things in simple ways and go quickly, rather than in ways that are good for other people to read your code later on. So realize that what you're doing here is not the only way you want to program. It's going to help improve your abilities, but it's going to also possibly form some bad habits that you'll need to break when you do other types of programming. There are people who perform a whole lot better without competition. I'm someone who actually kind of likes competition, right? It tends to, I like it. I think it makes me do better. There are other people who they really don't like it. I've had people like that who take this class and they still do okay in it. And maybe they sort of ignore the competitive parts. In fact, there are ways to ignore most of it. There are still the time constraints. But I want something for the people who do tend to do better with some level of competition. This is a way of building that up. But that's not for everyone. And then, like I said before, it ignores a lot of the bigger issues of software development. There's no life cycle. There's no idea of adding onto your code and building onto it and documenting it well and using comments and all that sort of thing. Okay, so what you're expected to know. 411 is a prerequisite. And what that means is I'm expecting you to be familiar with the concepts that are in 411. Now, there are going to be particular algorithms that we will probably go over again. We're going to talk about dynamic programming. We're going to talk about graph algorithms. And these are things that you would have covered in 411 or in 221. And some of them are going to be things that I will review and I'll say, yes, this is how you do it, and how you go through things that way. But I'm going to go through it very quickly, and I'm going to assume you've seen it before. I'm not going to explain the details of it. It's more meant to be a reminder and then show you how things get applied, rather than teaching it to you from scratch. So I know there are a few people in here who got my permission to take this class without 411. If that's the case, you might need to do background work. If you're someone who did take 411, hopefully this will come back to you quickly as we hit these topics again. Okay, the stuff that it was in 221, so this is like basic data structures and some of the basic algorithms like search and sort and tree manipulation and graph traversal. Those things that you had in 221, I'm just going to assume you know. I'm not even going to go over most of that sort of stuff. Okay, that's sort of the level that should just be ingrained within you as an upper level computer science student. Okay, someone says, are we gonna need to remember NP completeness? Basically, no. At the very end, we might get to some problems that are NP complete problems and how you would solve them in practice. But for the most part, no. And you're definitely not gonna have to do like proving NP complete problems or anything like that. So we don't do proofs. We don't do analysis in the same way that you would do in 411. This is not that type of class. It's more about implementing and applying. Okay, so because this is a hybrid class, I've been trying to figure out the best way to deal with this. So if I just record what's here and what I'm saying right now, I think it's maybe okay, but it's probably not ideal. So my plan is each week I'm going to produce a recording, possibly broken up into multiple parts, I don't know. But each week's topics, I'll have a recording for that. So for students, especially those who are going to be remote and aren't going to come to class, if you want to just sort of learn the core topics that we're trying to talk about, the concepts, you can watch the videos that will be posted each week related to that. And I should be able to go over that and you can review it and so on. And hopefully that will be a cleaner production than whatever I do in class where we stop and start and answer questions and so on. We'll see exactly how that goes. And the expectation is that everyone, even the people in person, will look at those videos to see those topics. I'm not planning to go through everything completely again in class. Okay, so class time will be in person. I'm going to try to stream it to Zoom every time, kind of like this. Hopefully I can get an adapter so that I can use my tablet and be able to write and sketch during class. If I have to use the podium computer, this is going to be not very useful at all for the people remotely. I might or might not record, I'm not sure. In the past, I've recorded stuff and not that many people have, like the graduate classes, people have gone back to, and the undergrad, not so much. So given that some things are gonna be recorded, I'm not sure I'll record every class, but I will try to stream them to Zoom. During class time, some of the stuff that we'll do, I'll answer questions. If people have questions about the topics that I've gone over after they've seen the video and anything follow up, I wanna be able to answer that in class. I'll try to go over and review problems. That's going to be one of the main things is every week there's going to be new problems. Every single week you'll have several new problems to work on. I'm going to go over how to solve each of those afterward. Okay, so after they're due, we'll go over how to solve them. We'll talk about that. And then we will demonstrate some implementations. So I'll try to code a few things here in class as we go. Okay, so let's see. One thing, if people in class have questions, just raise your hand. I will stop and answer questions for anyone who's here. People remote, I'm not sure if I might try to keep my eye on the chat to see if people have questions there, but I'm not always going to catch it. And it's kind of distracting to always have it up on the screen where it blocks some of the slides. So anyway, I'll try to figure that out exactly. But for those in class, anytime you have a question, raise your hand. I'll answer. Yes, question. So these recorded videos are separate from the lecture. Yeah, so I'm expecting them to be similar to what I might do in a lecture. Yeah, but like, you know, the first kind of real topic will be a bunch of hints about basics of sort of competitive programming style stuff. That'll be for next week and some basic data structure usage. So that'll be the first one that I'll record hopefully by Monday. So it should be up over the weekend at some point, if not before. Other questions? Yeah, so by the way, Dhruv is one of our TAs and he is in the class. He's on chat. Dhruv, thank you very much. So I'll assume you can answer a lot of the chat questions and that'll make life much easier if you're on. Okay. All right, so as far as kind of what we're going to do in class, there are going to be problem sets that you'll get every week. And I'm going to move some of these things out of the way after I admit people in the waiting room. Okay, so every week there's going to be problem sets. These are designed to focus on the topic of the week. So every week we're going to have some theme. So at the beginning, it's some basic data structure stuff. Later on, we'll go into like paradigms for solving problems like dynamic programming and greedy algorithms and so on, and graph algorithms and string algorithms and geometry and all that. Okay, and so each week, the problem set for that week will be focused on that topic. So you'll kind of know what you're getting at that time. Generally, those are going to be assigned on Fridays. Basically, they should be ready about lab time. That's my goal, but they should be sometime over the weekend. Generally, it'll be on Friday around lab time. And they will be due Saturday of the following week at midnight. Now, I've taught this class a few times before. It was a 489 before it was 430. So if you're wondering, oh, it's only the second time, it's actually like the fourth or fifth time. I've gone through different times when stuff was due. At one time, everything was due before lab. People hated that because they were like rushing to get their problems in, and then they had lab and they were already all worn out. And then we tried Friday night, and they didn't like Friday night because they were tired from lab and they didn't want to go work on more problems because of course everyone procrastinates till the last minute. Saturday seemed good. We actually talked about Sunday. People preferred Saturday because otherwise they were just going to procrastinate until Sunday. Anyway, Saturday seemed like the best. I will probably poll the class partway through, and if people really want to shift the time, I'm sort of okay for it to be any time within that weekend period. If it turns out Saturday is just not working. I will point out that office hours and help are only available during the week. So if you do it on Sunday and you don't start working a problem, it's harder to get help at that point. Okay, so each week, your problem set will be 3 to 6 problems typically. And then in addition, I'll try to usually add what I'll call a challenge problem, which is a very tough problem or a tougher problem that I don't expect most people to be able to answer. And so it is sort of a bonus one. You can solve it for extra credit. They don't count in the base score. So when I talk about score later, if I add a challenge problem or even 2, it'll usually just be 1. That will not go into the base score. It's more, hey, I did all the problems. I'm liking these. I want something that's really going to challenge me in this area. You're welcome to do that. Okay, for honors students, I'll come back to honors at the very end. But basically, people in the honors section of the class, 10 different weeks during the semester, there's going to be 1 problem less that you do. And you'll have an alternate assignments instead of that. Okay, so you'll have to look at that. You'll have to look at the discussion board on Canvas to see which one is the one to skip each week. Okay. I do see a question about the honors section. Yeah, if you want into the honors section and you're not currently in it, file a force request and maybe also let me know and I can ping the advisors to move people over. There's no particular reason you can't switch over if you want to, if you're eligible for the honors section. Okay, and a question about, are there in-person office hours? No, they told us we are not supposed to have in-person office hours. We're still supposed to do them remotely, so mine are in Zoom. I'll get to that a little bit later on. Okay, so the other thing is Fridays. So this class, lecture time is Monday, Wednesday. Friday is lab time. And so basically lab time, you can think of it as, it's a programming contest every Friday. 2.5-hour long programming contest. This very first Friday, the one coming up, we're going to start the contest later so that I can kind of review and make sure people are ready to go. But in the other weeks, it's just going to start automatically at 2 o'clock and end automatically at 4:30. And that's just the time period. It's always going to be there. There will be a set of problems that you'll get. You won't know them ahead of time. When the contest starts, you'll see that. And then you try to solve as many as you can during the lab time. Now, in the past, about 1/3 of the labs have been team labs because of the requirements for social distancing and the fact that everyone's online. We very well might do away with team labs this semester, which is actually not my preference because there's some nice things about teamwork and competitive programming. But for now, I'm not gonna do that. Okay, I do see someone says, I just checked, but said the application period for force requests is passed. Okay, if you want to switch over, let me know, send me an email with your UIN, and I can follow up on that. Okay, if you are coming in person to lab on Friday, make sure to bring your laptop. It's going to be over in Zachary in those rooms there. If you are in person, I will be in the lab. I'll be there to answer questions as you have questions, if you need help. If you prefer to be online, you just need to make sure that you are ready to program and submit stuff online during that time. There's a Zoom session that will be there, and the TAs will be online during the Zoom session. I might check in occasionally, but basically you can go there to try to get help from them, okay? Any questions on class or lab? Yeah. All right, the lab problems, part of the home. Yeah, so the lab problems and the homework problems all count equal. So every problem in this class is the same, even the really tough problems and the hello world problem that you have here at the beginning, they all count the same. Just raw number of problems. Yes. So for the problem sets, when you say time, do you mean like the runtime or? Oh, no. Yeah, good question. So the problem sets that you have each week, you've basically got a week and a day to work on them. And so I am assuming, no, I'm assuming that you will allocate your time appropriately there. It's not like the lab time when you're really having to code quickly. Yeah. No, it's not. But I'll come back to that part when I get to the grading. Good question. So you read the syllabus. What a concept. Most students don't. So. Okay, so I want to talk a little bit about time expectations and kind of what I expect and versus what people have told me they have spent. Okay, so I am reporting to you exactly what people have said on a prior survey that they spent on the class. So last spring, I surveyed people, this was before COVID hit, asking how much time they spent on various parts. And I asked how much time they spent on the weekly problems, upsolving, which I'll talk about in a minute, and then reading and studying outside. So one person said, and I think this was the maximum on the scale, they were spending 20 hours a week on solving and 20 on upsolving, which basically means they spent a full-time job on this class. Now, if you are doing that, that's a problem. That is not what I want you to be doing. That is way too much time allocated to this class. So please come talk to me if you find yourself spending an inordinate amount of time. The average time that people said they were spending was 9 hours, upsolving 4.5, studying 3. That is significantly higher than I want it to be. I actually reduced the problem numbers last semester, and these numbers went up from the previous semester. So I gave less work, and people spent more time. I don't quite get it, but my goal is to get this to about 9 hours a week that you're spending outside of class on problems. So that is higher than I know some people are used to having in your classes, but that is my target as far as what you would spend solving and upsolving problems per week. Okay? But realize it's probably not this is 2 or 3 hours a week outside of class. There are a couple of people who happen to do really well at these types of things, and they might be able to do them quickly and just spend a couple of hours, but the majority of people are going to have to spend more time than that. So just be prepared. Okay, a couple of special situations I wanted to mention. There is going to be a programming contest later on in the semester run by there's a new student organization, the Aggie Competitive Programming Club. And I don't know when the date is going to be, but whenever that is, it's usually been an extra credit option for people who want to do it. And if you can't do it at that time, I give you an option to do some of the stuff later and still get extra credit. We do have a few redefined days. They don't affect lecture time this semester, but they do affect our lab times. So one of them is we have spring break all of one day on 3/19. And so that Friday's lab moves one day earlier to the Thursday. And then we have a reading day on 4/2 that I believe is right before Easter. And so I think instead of that, you get a redefined Friday on Wednesday, 4/28. Okay, so, and that's the final day of class. So that will be the last time we meet. There's not a final exam in the class. There's actually no exams in the class. So we are not meeting during the final exam time. I will say when I talk about upsolving in a minute, that's the deadline to finish all of your upsolving. Okay, so final exam time is when everything has to be turned in, so I can get grades in. Okay, so the way grades work is it is just the percentage of the problem solved. So you will get problems every week in your weekly problem set. You'll get problems every week in the weekly, and in the weekly problem set, this does not include the challenge problems. So you'll have however many are there. I might give you, like here in the very first problem set, for those who looked already, there's 3 problems in problem set 0. They were meant to be super simple. 2 of them are super simple problems. 1 of them is pretty simple, okay? Those 3 problems are 3 just like any other one. Next week's problem set will probably have 5 or 6 problems, okay? And I might throw a challenge problem in, that doesn't count, it's still 5 or 6. Each week in lab, we'll have lab, and then I set a base amount, and normally I set the base amount based on what I expect people should be able to have solved in lab. Kind of an average student should be able to have solved this many. So if you're consistently undersolving, if you're consistently at the bottom, you are going to be low on points. If you're consistently doing better than average, you're going to be building up extra credit during lab, okay? So I normally am not going to know that until after the lab. I will let you know once I've determined it, but I wait and I look at the lab, I see what everyone's actually gotten on there, what I think was reasonable. So sometimes the class doesn't do as well as I thought they should, and the base might be higher than the average. Other times I feel like, hey, the class did great, I really only expected this, but you did better, and there might be a lot of bonus credit that week. Okay, all the problems count equally. I'm guessing, I don't know exactly how many we'll end up with at the very end, but around 100 to 125 is typical. It could be higher, it could be lower. This is a key thing. A problem is only solved if it's accepted, and that means that it passes all of the test cases on CATDIS. So CATDIS is the online system we're going to be using. You're going to submit your problems there. It's going to test those problems against a bunch of data. It's going to have like, 10, 100, who knows, how many test cases that it runs it against. It has to pass against all of them. And if it passes against all of them, it's accepted and you get credit for the problem. If it fails one of them, any one of them, you don't get credit, no credit for that problem. Okay, so the only way you get credit is to pass every test case on CATDIS. Okay, so if you solve stuff, there's a deadline for solving, right? The weekly problems are due Saturday night. The lab problems are due during the lab period. And that's what you do to get it for full credit. After that, there's what we're calling the upsolve period. So after the problems are due in a weekly problem set, or after the lab is over, at that point, you are welcome to discuss how to solve problems with other people. You're welcome to find out anything you want to about how to solve the problems. We will actually go over them in class the following week. And you have 1 more week. Okay, so for the problem set, you've got 1 additional week. For the lab, you've got a week plus a day and a few hours until the Saturday of the next week to what's called upsolve them. And the point of this is to show that you understand how to code up something that you know how to solve. So if you already know how to solve it, can you code it up? Can you implement it correctly? That's what the purpose of upsolving is. Upsolving problems gives you gives you half the credit, okay? So you get half credit for upsolving a problem. When you upsolve, and I'll put this online when we get to that point, there's nothing to upsolve at this point anyway, but when you get to the upsolving thing, as far as I can tell, CATDIS just recently changed how it works, but I don't have a way of checking it automatically online. I will need you to email me and tell me exactly what you've upsolved, and I'll give you the instructions for that online. Okay, if you have absences, basically if you are sick sometime during the week for 2 days or less, I'm going to assume that that just falls into that week that you had to work on stuff. Okay, and so I don't necessarily need to know about it. If you were sick for longer than 2 weeks, or you have some other excuse, absence for more than 2 days, for more than 2 days, then let me know and we'll do an extension on the assignment for you in that case. If you miss the lab, if you have an excused absence for the lab, the way that works is I just take those base problems out of your base score. Okay, so instead of you having 120 problems for the semester, you might end up with 115. Okay, it just won't count one way or the other. If you choose to upsolve those, you can still upsolve them for half credit, but I'll add the half onto the base also for anything you choose to upsolve. Okay. All right, so the final grade in the class, just percentage, 60, 70, 80, 90. There is one other thing. If you want an A in the class, I mentioned that every weekly problem set has a theme to it. So I don't want people getting out of this class with an A if they have not actually managed to get at least half the credit on each of the topics. So you have to get at least 50%. That could be you just upsolve everything. But you have to get at least 50% on all of the weekly problem sets if you want an A, in addition to 90% overall. Okay, so both of those things have to happen to get an A in the course. It's usually not that hard to do, but what that means is you can't just like do really well in the course and quit 3 weeks before the end. I actually had a student do that the first semester I taught this. He calculated exactly, I told him how many problems they were going to have exactly. He said, partway through lab, I've solved 3 problems. That gets me to 90%. I'm leaving. And that was the last I saw him. Okay, he didn't even bother to show up to class or lab, the remainder. And indeed, he got a 90% exactly. I don't want you doing that. He missed a few of the topics in the course. So anyway, you need to have half of that. The way this is going to work is Canvas. I will be recording grades there, but I will just say Canvas is not very friendly to keeping grades updated with this grading system. So when you see stuff about the total and all of that, you'll ignore it. If I can ever figure out a way to get Canvas to show it correctly, I will. But chances are I'm going to have to manually enter stuff and upload it occasionally to Canvas and tell you, hey, here's the current status. Okay, so don't get all worked up about one way or the other what it's showing in Canvas as far as your total grade. I will show you there, this is how many problems I show you had credit for. That part should be accurate there when it's entered. As far as languages, you can submit in almost any language, anything that CATDIS accepts. Python, Java, C++, any of those are fine. Sometimes it's better to use one language over another. So like Java and Python are good for big integers. Python's good for string processing. In the problems where efficiency is particularly important, I would recommend C++. It's usually the default choice. If you look at the big competitive programming people, usually they're programming in C++ because it's the most efficient. And if you have an efficiency concern, that's how you get efficiency. As a warning, Python 3 in CATDIS is notoriously slower than Python 2. And both can be much slower, like sometimes 100 times slower than C++. So just be aware of that. Many problems can be solved with Python. Many problems are not particularly time constrained, but if you are looking at one that's time constrained, that's something to be aware of. Java can sometimes be slower than C++. Occasionally it's significant, but usually it's not that far out of range. So if you're a Java programmer, you're probably okay. The examples I give, just because I tend to program in C++ myself, will mainly be C++ in the examples. Okay, I mentioned the CATTUS system. We're going to be using CATTUS for grading. So your CATTUS submissions and everything about CATTUS needs to be treated as your own. And what this means is you'll have to create a CATTUS account, submit problems through CATTUS. During lab, you'll have to go to the lab and submit them in the lab. Each weekly problem set, you need to submit them and have it show up there. Make sure that you submit under tamu.caddis.com. CATTUS also has open.caddis.com where you can just go solve problems. Okay, but if you submit it under open, I can't see it. I can see it if you submit it under tamu.caddis.com. Okay, so you have to go to tamu.caddis.com, go to our class, make sure you're submitting there when you submit your problems. You can keep your profile anonymous. So there's some instructions in the discussion board about signing up. Man, I hate these masks, sorry. There. There's some stuff in the discussion board about how to do that, but you can keep yourself anonymous if you don't want your name to appear to your classmates. Now, what you're actually doing will appear. There will be like a blank person there, and it'll sort of show what you're doing, but your name won't be associated. It'll be like hidden user or something. Okay, so if you really don't want other people to see how you're doing, do that. But I would encourage you, it sometimes is motivation for yourself to try to go ahead and be public with it, because it lets you feel some responsibility for what you've done, some accountability in what happens. And the main thing I would say is keep your CATTUS account private. Keep your login private. You treat this as though it's your net ID. Okay, we are not. CATTUS is not integrated with the Caste system. I will mention this right now. If A&M forces us to go and make it as part of the Caste system, we can do that, but then there is going to be a $35 fee per person from CATDIS. If we end up having to do this, which I hope we don't, we're using the free version. I assume you all would mostly prefer the free version versus having to pay $35 and getting the A&M account. If we have to, though, you will have to pay the $35 individually to do that, okay? So I hope that's not the case. We haven't had to do it in the past. I'm hoping we can continue that way. I just realized that if that comes up, you would have to pay it promptly. Okay, so we're going to discuss a wide range of things. If you look at the syllabus, you can see kind of the rough outline of what I'm expecting. But the rough current plan is about 4 weeks on the basics of programming and data structures, 3 weeks on search optimization, things like that. That's like dynamic programming and greedy algorithms, about 4 weeks on graph algorithms, and about 3 weeks on string and math and geometry algorithms. Okay, there is a textbook. So for those who are here, I will show you what it looks like. It comes in 2 parts, these little tiny paperback books. Okay, whoa. This is book 1, okay? This is book 2. Okay, the textbook is technically required, but I will say in the past I have required the book, and a lot of people said, even if they bought it, they didn't want to look at it, even if it had really useful stuff. I have a daughter who's a college freshman, and I have seen that people close to your age tend to not look at textbooks for some reason. I don't get it, but that seems to be the way it goes. So because of that, I'm not going to like enforce that you have to have this or read it. I think you will find it very useful to have it. The textbook has code examples, and one thing you are allowed to do is use code from the textbook. You're not allowed to use code from online. Okay, there's a whole thing about that. But if you get the textbook, you can use that. Now, this is the 4th edition. If you're particularly interested in these types of topics, I'd really recommend getting the books. In the 4th edition, you have to pay for them separately, and so they come to like about $43 total. There is also a 3rd edition of the book that you can get in hardcover or paperback or an e-version, and it's mostly enough. It's pretty much the same. Most of the things we're going to talk about are in both books. They're in slightly different orders. A few things are just a little different, but it's mostly the same. You'll be fine with the 3rd edition book if you want to get that. Okay, and then there's the CATDIS webpage that I hope to show you in a second, in our last 5 minutes if I can. So I'm the instructor. My office hours are basically an hour before this class, so 2:45 to 3:45. I also have times I can take appointments pretty much Monday through Thursday morning. I have time. So if you need an appointment on Monday through Thursday morning, you can do that. We have 2 TAs currently assigned, but Presley is remote, and they're making people do COVID tests if you're a student worker, and you'd have to pay like $200 a shot for a COVID test. And he's like, I'm not doing that. That's more than they would pay me to be a TA. So unless he can get a waiver if he gets a waiver, he can be our TA. Otherwise, he might not be. But Dhruv is. Dhruv took this class last year, did very well in it. He's great. He will be very helpful to you all. He has set up office hours Tuesday and Thursday, 2 to 3, Wednesday, basically right after class online, and Friday, right after lab online. So if you have questions, like to discuss lab problems, right after lab would be great time to do that. After class on Wednesday, and then also on Tuesday and Thursday. And either Presley, or if we have to replace Presley, I'll let you know about the other ones on time. There's different links for Dhruv's hours. Okay. So for this week, things that you need to do. First of all is go online, go to the Canvas page. If you are online, you've found the link already. If you're in person, you still need to go to the Canvas page because there are a few things there. So the first thing is there is a video on academic honesty, almost half an hour long. Because this class is one that it's very easy to cheat, for lack of a better term, it's easy to cheat in this class. I want to go through the details of what's allowed and what's not. There are also 2 acknowledgement classes on Canvas. They're basically, do you understand this? Do you understand this? And make sure that you acknowledge that. One of them is about use of CATDIS. One of them is about academic honesty. Then you need to go into CATDIS and set up an account and join our class. So that's 2 steps. You need to create an account on CATDIS, and then you need to join our class. When you join our class, it's going to ask for a password. It's my last name, Kaiser, spelled my way. If you go on Canvas on the discussion area, there are discussions. We are not using a third-party discussion site. In the past, I've used Piazza. I've really liked it, but Piazza changed their business model, and now they want to charge money. And so we're using Canvas for the discussions. My first time to do it. I hope it goes well. So please post questions about anything related to the class, even if it's whatever. Don't post your code there. Don't post, here's how to solve something there. But that's the place for discussion. Okay, problem set 0 is already up. Even though it is technically due Saturday night, because I didn't want to give you something that you had less than 2 days to work on, I would strongly encourage you to do them before lab on Friday. 2 of the 3 problems are super simple. One of them is literally hello world. Okay, and the point of them is just to get you used to how the system works. Okay, like what does it mean to submit a problem? Like how do I read input and output? And then one of the problems has to do with like how the scoring system works, scoring during lab. Now the actual score during lab is just for fun. The ranking and all of that is purely for fun. It's just the number of problems you solve that matters, okay? Don't assume that future problems are gonna be that easy. This was meant to just start you out. Okay, so this Friday, we'll have lab. Just like always, lab will start a little bit later, so I will talk to you in person and on Zoom before lab. I'll release the first real problem set. That'll be problem set 1. It's gonna be due Saturday of next week. None of these problems are especially advanced, and they will get harder over the semester, but there will be some challenging ones in both lab and during the week. We should have a video before Monday's class, and on Monday, I plan to review the problems from lab 1, as well as take questions. And then we'll see what on next Wednesday, it'll be different. Okay, so a couple of things to mention. Academic honesty, I mentioned that. The honors section. If you are in the honors section, look at the honors syllabus online, or there's an honors supplement. It describes how the honors part is going to work. Please find that on Canvas and take a look at it. Basically, you will do 10 fewer problems through the semester, but you will have to create 2 problems of your own. So you'll have to come up with the actual problem statement, the test cases, the verifier, all of that sort of stuff. Okay, so that's how the honors part of this works. We can talk more about that later. I do want to run through an example, but let me see if there are questions first, since we've just got 5 minutes left. Yes. Okay, question was on the CATDIS account, school email or just private. The email you use doesn't matter, but please use your name so that I can match it up to Canvas. So if you have, a lot of people go by a nickname or something. When you put your name in there, you can have a handle that's different, but I need your name to match your Canvas account, please, so I can match you up. Yes. Oh, on those 2 times? Yes. Mm-hmm. Those are redefined Fridays, so the whole university is switching. So unless you have a class at like Blinn or something, you should be okay. Okay, so I wanted to do a very quick, I'll do like one of the simplest problems possible on CATDIS, just so you can see how this works. I don't know if I'm gonna have enough time to do this, but I'm gonna do it really fast in these last 5 minutes, okay? So I need to put this mic down. Let me share this screen. Okay, so this is CATDIS. This is a very simple problem, but this is what a problem looks like. There's a title. It's going to have a ID associated with it. In this case, it's grass seed. This is one of the simplest ones. If you go to open.caddis, you can kind of see the difficulty level. 1.2 is about as simple as it gets other than hello world. And the basic thing here is it's talking about there's a little story. There's always some sort of story involved. But basically, there's a person who's wanting to sow seed on lawns. And for each lawn, it says C is the cost of the seed, L is the number of lawns, there's a width and there's a length, and it's going to have one line doing each one. Notice there will be sample input here for each of those things, and then the output should be a real number, and it's going to be check times 10 to the minus 6. So let's see. I'm gonna just show you solving on. I'll just run through it on cpp.sh for just a minute so that we can see how it works, and hopefully you can see how the submission process works. Okay, so CL and then width and length for each one. And actually, I don't remember which ones were doubles and which ones weren't. Okay, so that's a possible program there. So we read in a real number C, so that's a double, then an integer L, and then there's going to be L lines. I read this in as N, by the way, and each one contains a width and a length. And so I'm just going to multiply the width times the length to get the area, and multiply that times the cost C, and then I'm going to sum those things up. So I can take this sample input and hopefully copy it and try running this program and see if I made a typo. Well, oh, is there? I'll just do it this way. So let me check this out. 2, 3, 2, 3, 4, 5, 5, 6. Oops, the next 4, 5, 5, 6. And I guess I have to actually output something, don't I? And I might need to make sure the okay, so it outputs 112. So now I can take all of this as an example. When I'm back here in CATDIS, then I can go up here to submit, and you can either do a cut and paste, which of course this is not working well for me. Let's try this again. There we go. And submit. and it will run it. It says it's new. If I let it sit, now it's compiling. And it ran up against a bunch of test cases. Everything was correct. I got checks and I got it accepted. Okay, so that's what it looks like to submit a problem and get it accepted. Okay, sorry I went a couple of minutes over, but I wanted you to see a quick example of that. Again, try to do the sample problems from problem set 0 before lab if you're at all able to. But whatever you do, make sure you do the acknowledgement form before lab. Okay, see you on Friday. Yep. Sure. Trust me, I understand. I've been coming up to work